Welcome to the second attempt of making a mold plug for the right rudder of the UWS-1 Ultralight Airplane. From the Ultralight Airplane Workshop, I'm Leon. If you saw the previous video on trying to make this plug, you know that I had some troubles with this first one that I tried to make. Now, the major problem was that it wasn't the right size. When I printed out the templates for cutting out the foam, I had forgotten that printers frequently print smaller than actual size. So my rudder was definitely not long enough. Now I could have probably fixed the problem. I could have added about 1/10 of an inch of space in between each one of these sections of foam in here, and I could have made up the difference in length. Now the difference in cord, I probably also could have made up for it by adding a little more filler here on the front and or maybe a little bit more on the back. And also on the thickness. Another thing that was an issue though is the straightness on this trailing edge. In order for this trailing edge to be straight, the holes that I drilled, which I drilled by hand here for my stiffening rods, had to be exact. If they weren't exact, I was going to have a little bit of difference here on my sanding forms on this trailing edge. In addition, once this foam got pretty thin, which is about 1/10 of an inch, it was going to be pretty weak. It'd be easy for it to deform. Now, while I was coming up with this design, I was thinking of other ways of doing the plug too. And after I ended up with my length problem, I said, you know what, let's try version 1.1. So that's what we're going to do in this video. We're going to remake the plug with a different design. Let's get started. As you may remember from the end of the last video, I had an issue with my parts not being the right size. In particular, templates that I made from the printouts were not the right size. And I believe that's because printers frequently print a little bit smaller than 100%. So the first thing I did this time, making the new plug, is I went back to my Acrobat reader and I played with changing the scale in the print dialog. Different printers would need different scales because they won't all print at quite the same size. And what I calculated is that I would need 101.54 to get the right size. If I was printing a single sheet, I could do that. Clicking over here on size, I was able to put in the exact size I wanted. That worked great. But when I came over to do poster, which is what I have to do because some of my shapes are a little bit bigger than will fit on a single legal size page. So I have to do posters where it divides it up amongst several pages. Unfortunately, I only get 4 spaces to put in my scale. So I can put in 100 point or 101 point. I couldn't put in 101.5, which would have been good enough. So I thought about it for a while and I decided, well, the thing to do then is go back to my CAD program and change the scale in that. I printed it out here on my forms so that I would know. If I go to print on another printer, I will have to come back and change the scaling, unfortunately. But I calculated it. The scale has to be 1 to 0.985. That's basically the air inverse of 101.54. So once I did that, everything turned out pretty good. I printed out all the sheets that I needed for the plan form for the new style of the plug I wanted to make. I got a good measurement. I cut out all my paper plan form templates that I had printed out on the printer, and I laid them end to end just like they would be when I'm going to glue them down. I did a little bit tighter than what you see here, but when I got done and measured it, I got the top to bottom height that I wanted within about 20 thousandths, about 0.5 millimeter. So that's pretty darn good. I'm happy with that, so I proceeded on. Over on this left edge, you can see 3 black marks that are fairly close together. The one on the left is the only correct one. The other 2 were mistakes that I made. But the one on the left is the hinge line for the rudder. And it's a straight line from the bottom of the rudder up to the top of the rudder. I use that to line up the sheets that are the front half of the rudder because the hinge line is also printed on those sheets. So at each edge of the sheet, I just line up the hinge line on the sheet with the line that I drew on the wood. I also made some marks near the corners of where the leading edge, top and bottom, and trailing edge, top and bottom are going to be so that I know how far I need to spread my epoxy. And that's what you see me doing here. I'm laying down the epoxy on the wood, getting ready to glue the paper templates down to the wood to make the wooden template. The wooden template will then be used for the leading edge and trailing edge shape of the plug after we glue foam down to it. Spreading this epoxy is kind of boring, so let's jump to laying down the paper templates. We'll start with the bottom nose piece and then work our way up. Unfortunately, this video is somewhat overexposed, so you can't see the hinge line very well. But at least when my finger is near it, you can see where the hinge line is on the paper and where it is on the wood. I didn't show this for the planform sheets, but I decided I'd go ahead and show you what I'm going to make templates out of. 4 of my half airfoil sections will not fit on a single sheet of legal size paper, so they have to be printed out on multiple sheets. When I do that with Acrobat Reader, it puts these little marks up in the corner of the sheet. What I do then is use a long straight edge that I use a razor knife to cut between those marks. When I've done that on all 3 sheets, I can butt those sheets up together, and then I'll have the correct size drawing. I like to verify that the drawing is correct though. On each one of these drawings, I actually put a measurement in that is the distance from the leading edge to the trailing edge. Once I butt the 3 sheets up together, I can then get out my tape measure and verify that it really is the right distance. Sometimes I might forget to set the scale correctly in the drawing or on the printer, so it's a good idea to verify it. I don't need all this paper. My airfoils are not very thin. They're long, but they're not very thin, so I like to cut off the excess paper. As I said, 4 of my half airfoil templates takes 3 sheets of paper, but fortunately at least the other 5 will fit on just 1 sheet of paper. Now since some of these have to be on 3 sheets of paper, it's possible that I'll end up getting them separated and I might not know which one goes with which. So on each of the multi-sheet half airfoils, I put the correct section identifier on each of the 3 sheets. So for example here, this is the A airfoil, so I put A on each of those 3 sheets. And just for future reference, I also put the scale that I used in CAD so that these would print out the right size on the printer. I put those on the sheets also. Well, it's time to rough cut out the planform template for the rudder. I cut this out using the bandsaw, and I like to get within about 1 millimeter, maybe 1.5 millimeters from my line. I don't want to leave too much wood on there because it takes longer to take that off when I'm sanding down to my line using the disc sander. I'm cutting all 4 sides, the top, the trailing edge, the leading edge, and the bottom. Well, now it's time to remove that little extra 1/16 of an inch edge, and it's kind of a rough edge from the edge of the planform template. And I just use a disc sander to do that, just run it right along through there and trim that extra 1/16 of an inch wood down to the line that I have on my template. I want that edge to be pretty smooth because I want to be able to run a hot wire along it. Now it's time to start making the half airfoil templates. Half a set goes on one side of the planform template, half goes on the other side. 4 of these paper templates for the half airfoils actually take 3 sheets to print out. We've talked about that before on Acrobat Reader. The bottom of these half airfoils are perfectly flat, so that's a nice line to use to line up these 3 parts. The way I do that is I draw a line on my wood where I want that bottom half to be. And then as I'm putting down these sheets of paper, I just line them up with that line that's on the wood, and that lines up the bottom half of all 3 parts of the airfoil. The other 3 parts, though, are on one sheet, so I don't have to worry about lining them up at all. And just like with the plan form template, I spread out epoxy on the wood where I'm going to put down my paper templates. I then put down my paper templates. On the multi-part templates, I line the bottom of the airfoil shape with that alignment line that I drew on the wood. And then the other 3 on this piece of wood, I just fit them wherever they will up above. And then I ran out of space on this piece of wood, so there are 2 more templates on individual pieces up there in the upper left-hand corner that I'm also going to make. Then I make another set of these for the other side of the plan form template. To give you an idea how these half airfoils are going to be placed on the plan form template, we've got this little flyover here where we're starting at the top of the rudder, zooming around behind the leading edge, and then coming down towards the bottom. We'll have foam in between these half airfoils, and then of course we're going to have half airfoils on the opposite side of this plan airform, and you can actually see those at the top of the video here. They just haven't been cut out yet. Instead of using templates to cut out the foam between the ribs like we did on the previous plug, this time I'm just measuring distance between the ribs and cutting out the foam to that distance. And maybe just a little bit under, about a 32nd or about 3/4 of a millimeter less than that distance, just to make sure they'd fit in easily. Since we're not gluing the foam blocks end to end like we did in the previous plug, we're gluing them to the plan form template. A little space between these blocks is fine. We'll just fill that space with drywall mud. Now, these were the 6-inch spacings that you're seeing here. There were also 2.5-inch spaced foam blocks at the bottom, and then a kind of trapezoidal shaped one at the top. And we'll figure out how to cut that one out a little bit later. Here's another thing that's different this time around. This time I'm going to put spar caps along these ribs. And the reason for that is I'm concerned that this rudder plug is going to be too flimsy. I'm not going to glue the foam blocks end to end, so that certainly reduces the stiffness of the plug. So those little gaps in between the foam blocks, the only thing that's actually supporting it is that little thin 1/8-inch piece of plywood. And in fact, I did verify that just by holding it in my hand and doing a little bit bending. It bent far too easily. So I was concerned it would not hold its shape when I'm trying to put the fiberglass skin on it. So here I'm cutting out the holes for that spar cap. And the spar cap is just a 1/4 inch piece of oak that I had some scrap of. And they run end to end on the rudder. I also have to cut a place in that foam for that spar cap to run through. And we'll see that just a little bit later. Nearly all the video that I have of using a vertical hot wire cutter is with a fence. I thought, well, let's show a slightly different way of using it. And in this case, I'm just holding a square on the foam where I want to make a cut. And then I'm just pushing the foam through the hot wire with it just barely pushing up against that square. In this case, we're just cutting a 6-inch wide piece of foam to length that goes in between the half ribs on the plug. Now here's an example of how your first idea on how to do something doesn't always work out and you have to try something different. I wanted to glue each of these half rib templates to one piece of foam. That way later it would be a little bit easier to line up that piece of foam on the plan form template and then glue down each piece of foam. It would already have the rib in it, so I wouldn't have to worry about it being glued down. In other words, I don't have to glue down all the ribs and foam at the same time. Ribs are glued to the foam, and then the foam is glued to the plan form. Having too many things trying to be glued together and getting moved around is just too difficult to deal with. So here was my first idea for gluing the ribs to the foam. In order to keep them separated so that a rib wouldn't get glued to 2 pieces of foam, I put a little piece of plastic wrap around that rib and the foam it's supposed to be glued to. Then the idea was that I would press the 2 ends of the plug together to kind of press things up so that the rib would be pushed up against the foam as it's being glued and I'd get a nice glue joint. So as you can see from this point in the video, I'm just proceeding down through my blocks of foam. I'm applying epoxy to the rib itself. I didn't bother applying any to the foam because once again, I don't want to have to cut through epoxy with the hot wire cutter, which is what I'll be using later to cut the foam to shape. Now after I put pressure on the 2 ends and pressed everything together, I then weighted everything down so that the foam was all pressed down against the plan form, nice and flat. And then I went back through and I pressed each of the individual ribs down tight against the plan form. That way the bottom of the foam and the bottom of the ribs should be on the same plane, nice and flat. Unfortunately, that planned to have both the rib bottom and the foam bottom on the same plane, flat against that platform, did not work. Those darn ribs floated back up after I pushed them down. Now part of that is probably because I didn't have that plastic wrap nice and stretched out underneath that foam in the rib. I'm guessing just a little bit got bunched up under there, and that's probably what pushed those ribs back up. After I pulled this back up, after everything had cured, I had 4 of those ribs that were not pushed down flat. Now some of them were, and they worked out great, but 4 of them just completely failed. So for the other side of the rudder, I gave up on this idea and tried something else. I decided to fix these 4 blocks by sanding the excess foam off until I reached the flat of these half ribs. But I screwed this one up pretty bad, and it's more trapezoidal shaped than flat on the bottom. In order to fix this one, I decided to try something new. I decided to cut off that half rib using the hot wire cutter. And by golly, that worked out really well. I was really happy with it. After I got the half rib cut off, I just sanded off any excess foam and epoxy from the rib that I cut out of another block, and then I used a new method to glue this half rib to the foam block. Here's a dry run of my new idea for gluing these half ribs to the foam. I'll use a couple of small finishing nails to hold the rib in place so that the flat bottom part of that rib is directly in line with the bottom flat part of the foam. One of the things I did that wasn't necessary, I figured out later on, I countersunk the holes where I was going to nail in the nails so that the heads wouldn't stick up any. I was worried about trying to countersink them with the punch, especially on the aft end of the rib where there really isn't much wood there, and I was a little bit afraid that I was going to break the wood by trying to counter punch the head in. It turned out that I didn't even have to worry about sinking the head in. I just left it sticking out just a little bit. Since I already had a little bit of room between those foam blocks when I was going to glue them on, I didn't have to worry about sinking those heads in, so I quit doing the countersinking later on. After that dry run, it was time to do the real thing and glue this half airfoil template down to the foam. For this gluing job, I decided to use 5-minute epoxy. Before, when I glued up those half airfoil templates to the foam blocks all at one time, I used a much slower epoxy. It's the same epoxy that I've been using for gluing down the paper templates to the wood. Now using that slower set epoxy really slows things down. I have to wait 12 to 16 hours before I can do anything with it. With this 5-minute epoxy, it's much faster. Now it takes 5 minutes to start gelling, and it takes about an hour and a half to 2 hours before you can really safely handle it. They say an hour, but that's really not enough. But using this 5-minute epoxy really sped things up. After applying the epoxy, the only thing left to do is to line up the airfoil template back on the foam block so that the bottoms both line up, push in the finishing nails, and then press down on that airfoil to squeeze out any excess epoxy, and then wipe up that excess, because I don't want to have to try to cut through that epoxy with the hot wire cutter later. And then all it's left to do is to put some weight on top of that airfoil template and hold it in place for an hour and a half to 2 hours. This is the process that I use for the remainder of the airfoil templates and the foam blocks that you can see up here in the upper right hand corner. The top half rib gets glued to that top foam block that already has a half rib glued to the other side of it. Now trying to get that top rib hinge line lined up with the rib that's already on there, especially on this trapezoidal shape, would be pretty difficult to do accurately. So I decided to put off gluing that top rib on until later. But I do need to go ahead and cut out that 1/8 inch of foam at the very top where it has to sit. The way I tried to do it this time at least was I clamped a straight piece of wood an 1/8 inch up from where that next to last half rib is. That would push that foam block up 1/8 of an inch. Then I can use the top edge of the template profile to cut that foam. Then when I move the foam back down to 1/8 of an inch to glue it where it's supposed to be, I have that 1/8 inch gap then that I can glue that top rib into. It's time to glue together half of the plug. I will need to align the rib half templates with the lines that I have marked out for those templates on the profile template. I will also need to align the nose of those ribs with the nose of the planform template. Again, when I'm putting the epoxy down, I want to be careful not put too much on, because if epoxy squeezes out past the leading edge or trailing edge or the ends, that's just extra epoxy that I'm going to have to sand off, and I'd really rather not have to do that. Now it's time to put down the foam blocks. I first put them down in the correct order. I wanted to concentrate on order before I started concentrating on getting them properly aligned. It'd be bad to get it aligned and then realize I had it in the wrong order. Once I get them in the right order, then I start working on aligning the half airfoil templates on their proper lines on the planform template. And I line up the nose of that airfoil with the nose of the planform template. And I do that for all the blocks. One thing I forgot to mention, I put little finishing nails right at the edge of the planform at the nose of where each half airfoil template will go. That will help keep that airfoil template from floating too far forward. And what's kind of nice is that nail happens to go right in between the foam blocks, so it keeps the foam blocks from floating too far left or right. And I happen to also put some along the trailing edge. That really doesn't help the airfoil template from floating back, but it does still fit between the foam blocks and keep those from floating back there. So that helped quite a bit to keep things from moving around. And finally, I put some weights on top to ensure that the foam would be down flat against the planform template. Fortunately, I just happen to have some tile left over from some remodeling projects. I first used these 6x6 inch tiles, just one layer, to just get a little bit of weight on the foam to start with, but mostly to help lock them in place so they don't move around. And then once I get that first layer on, I put on a second layer, just a little more weight, and then once I'm fairly confident that the foam is locked in place, then I put the big heavy blocks of floor tile on. Once the epoxy gluing the foam down to the planform template has cured, that's about 20 to 24 hours, then I take off the weights, flip the plug over, and then repeat the whole process on the other side. Since I forgot to show you pounding in the small finishing nails on the other side at the nose of each airfoil template and along the leading edge and trailing edge, I thought I'd give you a quick glimpse of when I did it on the opposite side. Of course, I needed much longer finishing nails because now I have 1.5 inches of foam to deal with, but you can see it's the same thing. I put in a nail between each block of foam right up against the leading edge and the trailing edge. And like I said, that helps to align that airfoil template in the right place. My battery ran out while I was trying to capture this little recording, but I'll tell you what's supposed to happen, and then in the next clip I can show you the result. What I'm trying to do here is to glue the top two airfoil halves to the top of my plug. Over here on the right hand side is the top of the plug, and right in the middle you can see the top 1/8 inch of the planform template sticking out. So I'm going to put glue on each of my top airfoil templates. I'll lay those on the foam and line them up with my planform template. I'll also put a couple pieces of foam on top of that to help distribute some load, and then I'll put weights on top of that and then let it cure. Well, now you'll get to see what the end result was supposed to be for these top airfoil templates. First, remove the weights, and then I remove the foam that I used to help distribute the weight, and then reveal are the glued in place top airfoil templates. Next, we make a slot into the foam to install one of the spar caps. I've drawn a line right down the middle of where the hinge line is, and the hinge line is right where that spar cap is going to go. Since I'm doing this bow hot wiring by myself, I've cheated a little bit, and at the far end I have a square that is upright right over the middle of that hinge line. What I'll do is push the hot wire up against that square as I'm pushing the hot wire down into the foam to help guide me. And then on the near end, I'm just using my eyesight to guide it. I want to push that wire pretty much straight down into the middle of that slot. And you can see on the airfoil on this side, there's that little 1/4 inch notch in the airfoil. I want to go right down into the middle bottom of that notch. I then pull the hot wire toward me, which will be to the right. I'm going to pause for a moment because that hot wire on the ends moves faster than it does in the middle, and I want that middle to catch up to the ends. And then I'm going to pull that hot wire straight up out for about 1/4 inch, at least until I get up out of the notch in the airfoil templates for the spar cap. And then I'll probably move it out toward me just a little bit. That way it's kind of a funnel shape. And that gets half of the slot. Doing the other half of the slot is pretty easy. Now that I've got an open area there, a Y that I can push the wire down into, I go ahead and just drop it right down in there, into the bottom of the slot. I move the hot wire away from me until it stops. I pause for a moment so the middle of the wire can catch up. And then, just like on the front, I pull it up and I push it away from me just a little bit to make a nice open area that I'll be able to slide that spar cap down into. After removing the loose foam pieces from the slot, I can then do a dry fit of the spar to see if I did a good job of cutting that slot and if the spar is the right size too. It's a pretty good fit, so let's glue it in place. Gluing this spar cap into the slot was pretty easy. Again, I used the 5-minute epoxy. I spread it all along the length of the spar on just one side, and that will be the side that goes down into the bottom of the spar groove. I also dabbed some epoxy into the bottom of that groove along a few places, just in case I didn't get good contact between the spar cap and the bottom of that groove. The spar cap was a pretty snug fit down in that groove, so I was pretty happy with that, and I didn't think I needed to put any weight on that spar cap to try to push it down. Just left it like it was and let it cure. After that finished curing, I flipped over the plug and did the exact same operation on the other side, cutting the groove, gluing in the spar cap. I decided I wanted to use the hot wire cutter to remove some excess foam so I wouldn't have to sand it away. So I created a couple of templates to put on each end of the rudder that would stand off just a little bit from the airfoil shapes on each end, between 1/8 of an inch and 1/4 inch, depending on where it was. Then I could run the hot wire cutter along those templates to remove quite a bit of foam that I wouldn't have to sand. I started the hot wire at the nose and then moved it up and aft to the spar groove. And you can see I have some nice nose-shaped spare foam now from there. And then I dropped the hot wire cutter down into the spar groove again, and then I ran it aft to remove excess foam after the spar cap. And again, I got a lot of excess foam there that I pulled off. Before I did the same thing to the other side, I wanted to do a little sanding first while I still had a flat bottom. With this flat bottom on the plug, as I'm sanding it and putting pressure on it, that flat bottom will help prevent the plug from bowing or bending as I'm putting pressure on it. Now naturally, when I flip it over to sand the other side, I'll have to do something different. As I'm sanding this, I'm trying to sand down the whole surface at about the same rate, about the same thickness. So for example, I want to start at about 1/4 of an inch across the entire surface, and then sand down to around 3/16 across the entire surface, and then on down to 1/8, and then 1/16 across the entire surface. And the goal is to eventually reach the edges of my airfoil templates at about the same time across the entire surface. And the reason I want to do that is to avoid over sanding. If I'd stayed in just one area and sanded all the way down to the edge of my airfoil templates, then when I moved to an adjacent area and started sanding, naturally, occasionally, that sanding block would go back over that area that I'd already done once in a while, and I'd end up over sanding, creating gouges or a bowl or a trough where I've already sanded, and I don't want that to happen. There's no need to make you wait through all this sanding, so let's kind of jump to the end and see what it looks like. And here it is with the foam sanded. You can see here at the top, we've sanded clear down to the airfoil templates. And again on the bottom, sanded down to the airfoil templates, very nice. Trailing edge is nice and straight, which I could almost never get on the previous version of the plug. And again, you can see it was sanded down to a fairly narrow edge, and it's nice and rigid. And that trailing edge will nearly double in thickness after I've added the 2 layers of fiberglass on each side. Now you can see there are a few gaps in here. Part of those gaps are due to the foam having cuts made in it from the manufacturer so that you can actually snap it into 2-foot or 16-inch sections, and that left a lot of marks and gouges in it. And this trailing edge is sanded just the way I wanted. That back 1/4 inch or so of the trailing edge had to be sanded to a taper in order to get the thickness I wanted. So there you have it, the foam on the plug has been sanded. Now I am really happy with the way this plug turned out, especially this trailing edge. It is very straight, and because I used the template as my trailing edge, it's also very stiff. At least compared to the foam, it's very stiff. So I am really happy about that. And of course, because I printed out my templates to the correct size, everything on this is the correct dimensions. Correct cord, correct length, correct thickness. So I'm really tickled about how this turned out. Now there was more sanding involved in this, the way I did it, than the first one would have been. But it wasn't bad. It took about a half hour or so sanding on each side. So that turned out pretty well. So the next thing to do is to fill all the gaps, all the holes, and any unevenness with drywall mud. I will then sand that down, and once we get a nice smooth shape on that, it'll be time to cover it with 2 layers of fiberglass. Once I have the fiberglass on, again, I'll put a little skim of drywall mud on it, sand it down to try to get the final smooth surface, and then we'll put a finish coat on it. So all that will be in the next part, which will be part 4. I want to thank my patrons for keeping this project going. They've been a fantastic help. And I really want to thank my designer level patrons, Keith and Richard, for helping out a whole lot. Thank you very much. Until next time.